so this is a bit different than how it works in Python. So in Java, before you use a variable the first time, you have to declare that it exists, and in doing that, you have to specify its name and type. And so here, we declare the variable called result, and we initialize it with the value c. In Java, this means that I can use the name result from this point to the end of the block that result is defined in. So the code that's written here is fine, right? Result is declared here, I can use it here, I can use it here, and I can use it here. If you try to write this code the way that you would write a Python code, so for example, you don't declare result before the if statement, but instead you declare it when you know what the value of result ought to be. So here I know that result should be A. The problem with this in Java is that here's where you declare result, and it's only usable inside the block that it's declared in. So it's declared inside of this block here. After this block is finished running, the name result is no longer usable. And that means if this line runs, the else statement won't run, right? Because that condition is true, right? This line runs, skip over the else statement, and now you get to here, right? And when you get to this point here, there is no variable named result, right? The scope of result is just this line here. So when it gets to the return statement, there's an error, right? There is no variable named result at this point. So you have to be a little bit careful about this in languages like Java and C. Okay, so you might have been taught this in your 121 class or in 101, I suppose. If a function or a method in Java returns a result, you have to have a return statement. You're allowed to have more than one, but there are some rules regarding what code you can have. Sorry, you're allowed to have more than one, but what you're not allowed to do is after a return statement, try to insert some code, right? So here, I know that A must be the larger of the three values, so I immediately return A. A return statement stops or ends the running of a method. The same is true in Python. So if you return A here, it doesn't make any sense to put code here. This code will be unreachable, right? It'll never run. And so the Java compiler will actually check if this is the case. If you try to insert some code here, you'll get an error, right? Not when the program runs, but when the program is read by the Java compiler. Right? Similarly here, right? So if this condition is not true, but this condition is true, then I know that B must be the larger value, so I can simply return B here. Again, you're not allowed to put any code here. That code would never run anyway because the return statement stops the running of the method. Finally here, if that condition is not true, that condition is not true, then I know that the answer must be C, so I can simply return C down here, right? And this eliminates the extra variable named result. Right? Again, no code allowed after the return statement. You might have been told in a previous course, perhaps in high school, that you shouldn't write code that looks like this, right? You should always try to write code that has a single return statement. So that's nice in principle, but in practice, you will see code written in this style, right? The reason you want to avoid having multiple return statements in a method or function is that it can be hard for somebody else to come along to read your code and reason about what your code is doing because you've got these return statements all over the place. Right? I would argue that this method is pretty simple, and anybody reading, any moderately experienced programmer reading this code would have no trouble with the three return statements. Right? But you may occasionally run into somebody who tells you, hey, you shouldn't write it this way. Right? Make a variable instead. Assign the result to the variable and return the variable at the end. Right? In this course, I don't really care which way you write it. If you want to write it with multiple return statements, go ahead. Right? If you want to make a variable and store the result in the variable and have only one return statement, go ahead. That's fine. Okay. Yes. One of the things you have to be careful about, your compiler is not a mathematician or a logician, right? It cannot work out mathematical, or it does not try to work out mathematical logic for you, right? And so you might say, you might try to write the if statement this way, right? So if A is the larger value, return A. else if B is the larger value, return B, else if C is the larger value, return C, right? And you might say, well, look, mathematically, this makes perfect sense, right? I've got 3 arguments here, A, B, and C, right? One of them must be the largest value, right? My if statement here has 3 cases, so, and they all return A, B, or C, right? This ought to, mathematically, this makes sense, which is true, right? Unfortunately, to the Java compiler, it does not, it's not correct, right? So all that the compiler does is it looks and says, you have an if statement here, you have an else if part of the if statement here, and you have another else if part of the statement here, right? So that's all it sees, right? Now, when you have an if statement or an else if statement, right, that might be true, that might be true, that might be true, right? So as far as the compiler is concerned, any one of these could be true, multiple of them could be true, or none of them could be true. It doesn't look at the conditions and try to deduce that, in fact, this covers all possible cases. So as far as the compiler is concerned, it's possible to get past this if statement and end up down here, right? Even though mathematically it's not, right? The compiler says, look, that might, so this line might run, that one might run, that one might run, or none of them might run. If none of them run, you end up down here, right? And as far as the compiler is concerned, that's a problem, because you made a method that said it returns a value, and you don't have a return statement down here, right? And so the correct way to solve this problem is to strike the if part here and just use else, right? So if you use an else here, so else return C, right, then the compiler knows, oh, this if statement always returns something, right? It either returns the A, returns the B, else, get rid of all this, right? The else handles all other cases, so here it says, oh, you're returning C here. So now it figures out, oh yes, this function will return a value, and it doesn't complain, right? So compiler, not a mathematician, right? It only looks at the structure of your program. All right, so you may have been wondering what the heck is this double ampersand that's flying around, right? In Java, if you want to combine 2 conditions such that the overall condition is true if and only if both of the subconditions are true, you want to use AND, right? So the word AND in Python is the logical AND operator. In Java, it's the double ampersand, right? Don't use the single ampersand, right? The single ampersand means something else in Java, right? It's bitwise AND. So it takes the bits of the value on the left, the bits of the value on the right, combines them together using what's called bitwise AND. You learn about that in 220. So if you use the single ampersand, this has to be an integer value. Is that true? If you use single ampersand, I forget what happens if you use it with Booleans. I don't want to take the time to try it out right now. But really what the bitwise AND is meant for is you're meant to combine 2 integer values. Right. So the double ampersand is your logical AND operator. So instead of writing the words AND, you write double ampersand. Like in Python, the ampersand operator, the double ampersand or the AND operator is called a short circuit operator. Right? And so what that means is that Java will look, we'll look at the condition here, right? So is A greater than or less, greater than or equal to B, right? If that's false, it never evaluates that condition there, right? Because false and anything is false. So it knows the answer right away. So if that's false, it knows the answer right away is false. It never even tries to evaluate that thing there, right? If this part here is true, then it will go ahead and evaluate the second one to also check if it is true, right? That's not super important for this course. It is possible to write code that is, it's possible to write code where if you switch the order of these 2 things, your code becomes incorrect. I don't have an example of that right here, but be aware of the fact that it is possible that Some programmers will take advantage of the fact that this thing here is a short circuit operator, so it won't evaluate that if that is false. And that can, and if you flip the two conditions, you'll end up with code that doesn't work the way you want it to anymore. Right? If you want OR, that's the double vertical bar. Right? The single vertical bar is bitwise OR. So again, not the one you want. Right? So you want the double vertical bar, and has higher precedence than OR, just like it does in mathematics and like it does in Python. Right? So here I'm writing a method that takes in an integer year and checks whether or not it's a leap year. Right? So most people know that a year is a leap year, or most people think that a year is a leap year if it's divisible by 4. And that's not completely true. Right? So a year is a leap year if it's divisible by 400, right? If it's not, or if it's divisible by 4 and not divisible by 100, right? So is the year divisible by 400? Yes, it's a leap year, right? Is it divisible by 4? Well, yes, as long as it's not also divisible, as long as it's, if the year is divisible by 4, it's a leap year as long as it's not divisible by 100, right? So for example, 2000 is a leap year, right? Because it's divisible by 400. 2100 is not a leap year because it's also divisible by 100, right? Not divisible by 400 is divisible by, right? Okay, so how do you write that as a condition, right? So is the year evenly divisible by 400? So Java's percent operator is the remainder operator, similar to Python. Right? There are some subtle differences between the two operators, but they behave more or less the same. Right? So if that's an integer value, right, percent 400 means take the value, divide it by 400, right? And then it returns the remainder of the result. Right? So if the remainder is 0, you know that it's evenly divisible by 400. Right? So 2000 divided by 400 is 5 with a 0 remainder, so it's evenly divisible by 400. Right? 2100 divided by 400 is 5 point something, right? So it has a non-zero remainder, right? And so that condition will not be true. Right? All right, so the other part of the is it a leap year is that it must be divisible by 4, right? And so to check if it's evenly divisible by 4, take the remainder after dividing by 4 and check if it's equal to 0, right? Notice Java's equality operator is equals equals, right? Right? So is the year divisible by 4, right? And is it not divisible by evenly divisible by 100, right? And so take the year, divide it by 100 and look at its remainder, right? And then check, is it not equal to 0? So not equal is exclamation mark equals, right? Python has the keyword not, right? Java does not, right? You must use the exclamation mark instead. So not exclamation is not equals to, right? So if these conditions, if one of these two conditions are true, then the answer is true, right? Otherwise it's not, and you return false, right? Okay, this, the way this is written here works because the and has higher precedence than the or, right? And so when Java goes to evaluate this condition, it evaluates that and that, takes the and of those two conditions, right? And evaluates that, or, and the overall result of this condition here. Right. Okay, so if you want to, if you're worried that you might have an issue with precedence, you can always use parentheses to impose your, force the second condition to be evaluated first, right? So if you don't want to remember that and has higher precedence, or if you want to make it clear that you want to evaluate all of this stuff first, right? You can always wrap it in a pair of round brackets, and that will force the stuff inside the round brackets to be evaluated first, right? You can't use square brackets, you can't use braces, right? It's always round brackets for parentheses. Okay, so just a quick note on this little piece of code. Many beginner programmers will write code that looks like this. right? So if some condition is true, so this condition up here doesn't matter, right? If some condition is true, return true, right? Otherwise, return false. Now, what you should start to try to remember is that all of this stuff up here is a condition, right? It's either true or false. So you don't have to check whether it's true or false to return true or false, right? You can just evaluate the condition and return the result. So the better way to write that piece of code is to do that, right? So evaluate the logical expression. It's either true or false, right? And so simply return the result of the logical expression, right? The if statement here is not required. In this course, it doesn't matter if you write it this way, or this way, right? No one, well, hopefully the TAs don't deduct any marks from you, right? I certainly won't, right? So it doesn't really matter at this point in time, right? But as you, especially if you want a career in programming or that involves programming of some kind, right? You should start to train yourself to recognize all of this stuff is either true or false, right? I don't need an if statement to check its result to return whether or not it's true or false. Right, so keep that in mind as you become more experienced in programming. Okay, so as I mentioned before, not is the logical, not, if you want to negate a condition, the exclamation mark is going to be involved in some way, right? So for not equals, exclamation mark equals, right? If you want to negate a condition, so turn true to false or false to true, that's also the exclamation mark. Right? So assume we have this method is leap year somewhere. I'm going to assume it's in lecture 3, right? Remember, all methods have to be in a class somewhere. So let's assume it's in the class lecture 3, right? I make another class and I want to use the is leap year method, right? So I import lecture 3, maybe, and then in my code here, when I call it, right, I write lecture 3.isLeapYear, right? And so this returns the number of days in February, right? If the year is a leap year, it returns 29. If it's not a leap year, it returns 28, right? So I can call isLeapYear, that returns true or false, right? I can negate the result, so there's your exclamation mark, right? So if not, year is a leap year, right? Then I know that there must be there's 28 days in February, otherwise there's 29, right? Of course, you could write this the other way, right? If lecture 3 is leap year, return 29, otherwise return 28, right? The only reason I wrote it this way is so that we could use not, right? So if you want to negate a logical value, use the exclamation mark, right? In Python, it's the keyword not, right? In Java, it uses the exclamation mark operator. So there is another unusual thing for Python programmers when they switch to Java. Python lets you chain comparison operators, right? And so here I'm passing in a numeric grade and determining what the letter grade is based on that numeric grade, right? So here I'm only doing A, B, C, D, and so on and so forth, right? But you can easily change this to do A plus, A minus, and so on and so forth. Right? So in Python, you might write this function like this, right? If the grade is greater than or equal to 80, the result is an A, right? Now, Python lets you chain the result of two comparisons. So if the grade is greater than or equal to 70 and less than 80, right? So that's perfectly fine in Python, right? Which is nice, because that's the way a mathematician would probably write it, right? You can return B, right? And so on. Right? If you try to do this in Java, it doesn't work. Right? So in Java, you cannot chain comparison operators like this. Right? So no chain comparisons in Java. Right? Really, what the programmer is saying here, right, is the grade greater than or equal to 70, right? And is the grade less than 80, right? And so Java makes you write all of that out explicitly. So down here, right, you have to write else if, round brackets, right, is the grade greater than or equal to 70, and is the grade less than 80, right? And so on, and so on, and so on, right? So if you want to write a chain comparison like this, if you're in Python mode and you want to write something like that, you have to remember you have to translate it to that instead, right? You need to use the AND operator here. Oh, okay. So that's the end of that lecture deck. So that's basically how to write an if statement and use logical expressions in Java. Okay, so to complete the assignment, you need to know how to use arrays, and you need to know how to write some loops. So that's the next lecture. So that's lecture deck 4. Okay, so in Python, you learned that there is this thing called a list, and you've probably seen lists more than you want to, right? So you almost certainly use them for many, many different things in 121, right? They are very useful, right? That's why they are built in type in the Python language, right? In many computing programs, you don't want to do something with just one thing. You've got lots of things that you want to do something with, right? You have to store the lots of things somewhere. So something like a list is often an appropriate container for those things. Right, so in Python, I want to make a list T. This one has a list of 4 strings, right, A, B, C, and D. You should know, or should remember, that to get an individual string from the list, you use the square brackets, right? So we say we index the list using an integer index here, right? Python is a zero-based language, is a zero index-based language, so all indexes start at 0. Same as Java and C, right? There are some languages out there that are 1-based, so the first element will be at index 1, but you probably won't run into those. Your first instance of seeing it might be Sys271 if you take Sys271. And there you'll learn a language called MATLAB, which is a 1-based language. Python is 0-based though, and so is Java, so that's great. If you want to get the last element out of a list, in Python it makes it easy, right? In Python you can use -1, right? The hard way to do it in Python, the last index in a list is the length of the list -1, right? Remember, the length of the list is the number of elements in the list. We start counting at 0, so I have to subtract 1 if I want to get the last element. So the hard way to get the last element out of the list is to compute the length of the list and then subtract 1, right? The easy way, of course, is to use -1 because you can use negative indexing in Python. Right? To set an element of the list, it's the same thing, right? T1 lets you set the second element of the list, right? So I can set that to B. T2 lets you set the third element. T3 would let you set the fourth element. If you tried to write T5 equals something, I actually don't remember what happens in Python. The sensible thing would be that an error results. I believe that's what happens, right? So if you try to set an element of the list that doesn't exist, that's an error, right? So there's 0, 1, 2, 3. So if I try to use T4, I would expect there to be an error there. Okay, so Java does have lists, but we're not going to talk about those for a couple of weeks. Instead, I'm going to tell you about something called an array, right? So an array, the reason I'm telling you about an array is because the syntax for using an array looks a lot like this, right? In fact, so it uses the square brackets. The problem is Java arrays aren't the exact same thing as Python lists, right? So remember a Python list, you can add stuff to the end of the list, right, by appending elements to the list. You can remove stuff from the list by removing elements anywhere in the list, right? And you can insert anywhere into the list, right, using an appropriate function in Python, right? So that's not true with a Java array. Okay, so in an array, you have a fixed number of values of a single type. That's the other big difference, right? Here I've got a list of 4 strings. But there's nothing stopping me from adding an integer at the end, right? Or writing T0 equals 2, for example, right? Python list can store elements of any type. A Java array can store elements of exactly one type, right? They all have to be the same type. An array has a length, but it's fixed. Right? So if I make an array of length 5, it always has 5 elements in it. There's no way to change the length of the array. Right? I can't make it smaller. I can't make it bigger. I cannot remove stuff from the list. Right? From the array, sorry, from the array. You can't add new elements to the array. You can overwrite existing elements in the array, right? But you can't put new ones in. Sorry, you can't make the list longer. You can't make the list shorter. Okay, so an array is just a type in Java. So just like any other type, if you want a variable that is an array, you have to declare the variable. So when you declare the variable, you specify what is the element type. So here, collection is going to be an array of double, right? And then you put square brackets after the double. And so this tells Java collection is going to be an array of double, right? Or at least that's what it looks like it says. What it's really saying is that collection is a variable that can refer to an array of double, right? So I don't have an array yet. I have a variable, right? The variable here holds nothing, right? There is no array yet, right? So in Java, if you were to look at the value of collection, so if you print collection, you'll get the word null, N-U-L-L. Null means no object. Here it means no array. So you don't have an array yet. You've got a variable that can hold an array, but you don't have the array yet. Right? Okay, so once you have the array, right, you can use it in a way that's similar to the way that you use a Python list, right? At least all of the basics, so indexing and getting its length, right? Those are similar to what you would do in Python. So this code here, you could translate to this here. All right, so our Python list was a list of strings, but all of our strings were a single character long, right? Java has this type called char. Right? Char is the type that's used to represent the individual characters in a string. Right? Python doesn't have that, right? So Python says that a string is made up of other strings, right? So back here, right? Python says that the string A is made up of the string A. Right? Java says that a string is made up of a bunch of chars. So here, I'm going to use a single character A. Right? Here's a single character B, here's a single character C, and there's a single character D. Right? To indicate that you have a char, literal, you put the one character in between single quotes. Right? So you can use single quote 1, and that's the character 1. It's not the numeric value 1, it's the character 1. Right? And so on and so on and so forth. You can put a space in, so single quotes space inside. What you can't do is you can't write single quote, single quote. There is no empty character in Java. Right? Similarly, you can't write single quote AB. Right? All characters are one long, except for the ones that aren't. Never mind about that. Right? Okay, if you want to get the first character out of an array, you can use the square brackets. Right? So T0, that's the same. That's a similar thing to writing T square bracket 0 in Python. Right? You get the first element out of the list, or first element out of the array in this case. Right? Again, if I want a variable, I have to declare it before it's used, so I have to say char first. Right? Char, because the elements of this particular array are all of type char. Right? If you want the last character in this array, right? Again, make a variable called last. Its type is char. Right? Use indexing to get the character out of the array. Right? So for Java arrays, there are no negative indexes. Right? You have to do it the hard way. So to compute, you have to compute the last index of the array. So there is no length function in, or len, L-E-N function in Java. Right? To get the length of an array, you have to write array name, so that's T, then a dot, and then the word length. Right? So technically what this is that length is what's called a field belonging to the array T. Right? So you can think of it as being a variable that belongs to T, and its value is always equal to the number of elements in the array. So here, T.length is 4, right? 1, 2, 3, 4. Right? You can't change T.length. So if you wrote T.length equals 5, the compiler will flag that as an error, right? So you're not allowed to assign to the value T.length. Right? So the last index of the array is the length of the array minus 1, right? And that will give you the last character. To set elements of the array, it's the exact same thing as with a Python list, right? Use square brackets to index, and then assign a value to the element in the array. Okay, so using the array, you can think of it as just like using a Python list, right? As long as you're using simple indexing, right? You can't slice an array like you can slice a Python list. You cannot use negative indexes. You'll end up with an error, which is called an exception in Java, and you must specify the element types. Okay. Right. Okay, so to make a list, so the one way that you can make an array is to initialize the array when you declare it, right? So here I'm declaring the array T for the first time, right? If you know what you want to put into the array, you can use the braces and then put the elements in with a comma-separated list, right? So this would be similar to using square bracket A, comma B, comma C, comma D in Python, right? The difference is you can only do it when you initialize the array T, right? So in other words, the only place that I can write something that looks like that is when I declare that T is an array of car. If I try to write the following, so car square bracket U, right? And remember, this says that U is a variable that can hold an array, but there's no array yet, right? If you then try to write U equals squiggly brackets X, Y, Z, you'll get an error, right? The compiler will say you cannot assign to an array variable, and that's true, right? In Java, if you have an array variable, U or T, right, you can't reassign that variable to be something. You cannot assign an array to that variable. Right. Sorry, that's not true. You cannot use the, it's true in C. In Java, you can reassign to it. So in Java, right, you cannot use the squiggly brackets except when you initialize. Right. So what the more normal thing to do in Java is, because normally you don't know what you're going to put into the array. The more normal thing to do is to make an array and then fill in the elements of the array, right? And so what you would normally do, right, is you would make your variable and then you make your array. So the way you make an array is with the new operator, right? And you're going to see the new operator used over and over and over again, week 3 or 4 of the course, right? So the new operator in Java is the operator that makes an object. It doesn't make primitive values. It'll make objects, which I'll tell you about later. Right? It turns out an array is an object in Java. So to make a new array, you use new, right? You say, what is the element type of your array? So here, collection is an array of double. So I write new, double, and then square brackets, and then the number of elements you want in your array. Right? So this number here can be any value greater than or equal to 0. So you can make an empty array. Right? The empty array can never hold a value. Right? If you make it 1, that array holds exactly 1 element. If I make it 10, then collection is now an array, or now refers to an array that always holds 10 double values. Right? So that number 10 is called the capacity, or the length of the array. If you write collection.length, somewhere down here, right, that'll be the value 10. Right. Okay, so when you make an array of primitive type, all of the elements of the array get a value. So remember, arrays are funny in Java, right? When you make this array here, you get an array of 10 doubles, right? And so the language has to fill in the values of the array with something. There's 10 double values, we have to put something in for these double values. So what Java does, when you use the new operator and a primitive type, right, it chooses a default value for all of the elements in the array. Right? So when you write new Boolean, all of the elements get set to false. So some bools is an array of 3 false values, right? False, false, false. When you use a numeric value, they get set to 0. So some ints, new int 4, you get an array 0, 0, 0, 0. Right? Some doubles is an array of 5 double values, so you get an array 0, 0.0, 0, 0.0, 0, 0.0, 0, 0.0, 0.0, right? 5 double values. Another slightly awkward thing about using arrays in Java is that you can't print an array directly. Right? So if I write out system.out.println and then some bools, right? What you get back is just some strange number. It's some strange combination of numbers and letters. Right? If you actually want to print out the elements of the array, you have to ask another method to convert the elements of the arrays to strings and then print out the resulting string. So the way you do that is you use this method called, this class called big A arrays, right? You call its toString method and you pass in the array that you want to print, right? Notice that using arrays is a lot more awkward than using Python lists, right? You have to import that class called arrays with that statement up there. And probably in the next lecture or so, I'll tell you exactly what this java.util.arrays nonsense actually means. Right? Okay, so for your primitive type arrays, all your elements get set to a default value. Right? False for Boolean, 0 for all you numeric values. Right? Notice that char, remember I told you char is the type that's used to represent characters in a string, right? The individual elements of a string. It turns out in Java, char is just a numeric type, right? So your character A corresponds to some number, some char value that is actually a number, right? If you make an array of char, all the values get set to the numeric value 0. It's not the same thing as the character 0, oddly enough. Okay, if you if you're not happy with the default value of 0 or false, you want something else, you can always ask this class called arrays to fill in your array with some other value. Right? So here I have an array of doubles, 10 double values. Right? If I print that out, I'll get 10 0.0s. If I wanted an array of 10 ones instead, I can fill the array with the value 1.0. So you call what looks like a function, it's actually a method. Right? So arrays.fill, pass in the name of your array and the value that you want to fill the array with. You can only pass in one value, right? So here you can only fill it with one thing. If you want a sequence like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you have to write a loop and fill it in yourself. Right? Okay, so the number of elements in the array, you use the array name and write .length, then that tells you the number of elements in the array. Right? That's an int value in Java. Right? So here n will be equal to 10. Right? If you leave this line out and write int n equals collection.length, you get an error. Right? So be careful about that. Right? So again, remember when you write this line of code here, there is no array yet. Right? You've got a variable, it can hold an array, but there is no array yet. Right, which is a bit unusual, especially coming from a language like Python. Right, here, now there's an array. Right, so now you can ask for its length. If you took this line and moved it up here, you would end up with an error. Right, oddly enough, you end up with the error when you run the program in this case. Right, and you'll get something called a null pointer exception. Right, and you'll get some error message that says there is no array called collection. Okay, so the elements in the array, so the values in the array are called elements, similar to, hopefully they called them elements in your 121 class, right? So similar to the values in a Python list, right? The last valid index is always the length of the array minus 1. The first valid index is always 0. If you try to use an index outside of that range, you'll get an error. Right, so here's an example where I make an array. Oh, sorry, I'm going to assume, oops, sorry, back here. Right, so let's assume we've run this line here. So we have an array of 10 values. Right, I can now fill them in, manually in this case. Right, so the first element is 100. Right, if I want to get the first element, I can just use the index 0. Right, you can use any index here up to 9, and that's fine. Right, remember that Java fills in the values of the array for you if you haven't done it already. Right, I can go ahead, fill in the rest of the values that I want. If I try to use a value that's out of range, right, so equal to the length of the array or negative, you end up with what's called an array index out of bounds exception when you run your program. Right, so Java, just like Python, will check an index before it actually tries to use it. right? If the index is not valid, in Java you get an exception. In Python you get an error of some kind. Okay, so now that you've got your loop, now that you have an array, you have multiple values, right? You probably want, many of the operations that you want to perform on the array probably involve doing something with all of the elements in the array, right? So you need a loop now. So when you're working with a Python list, right, one of the most common things that you do is you loop over the elements of the list. Right? So if I want to find the maximum value in a non-empty list, one way to do it is to write a little loop. Right? So here I've got a function called maxElem, finds the largest element in T. Right? This only works if the list is not empty. Right? If the list is empty, then T0 will cause an error in Python, just like it'll cause an error in Java. Right? I'm going to assume the first element of the list is the largest element. Right? And now I need to look at all the other elements in the list. So in Python, Python only has one for loop. Right? So Python has a for each loop, and that's all that it has for loops. Right? So for every element in T, right, it's going to go through the list starting at index 0, and the first time through the loop, elem will be equal to T0. Right? Second time through the loop, elem will be equal to T1. Third time through the loop, elem will be equal to T2, and so on and so on and so forth. Right? So if you find an element that's greater than the current largest element, you know that your new largest element is equal to that value. Right? Process all of the elements in the list. When you're done, return high. Right? Return the largest element that you saw. Okay, so Java also has a for each loop. Right? So I want to make a Java method, so public static. Right? Now remember, Java methods, if they return a value, you have to say what type of value is it returning. Right? So to determine what type of value it's returning, I have to decide what kind of array am I looping over. Right? So notice Python here, this will work with an array of any type, as long as you can do greater than. Right? So you can use a float, or you can use an array of int. You can use an array, a list of ints and floats. This will work just fine in Python. In Java, that's not the case. Right? Here, I can process an array of doubles. Right? If I want to process an array of int, I have to write a separate method to do that. Right? So if I want to find the largest value in an array of double, I'm going to return a double value. Right? And now the code basically looks the same. Right? High is going to be the current largest element that I see, so that's going to be the element at ARR0. Right? And now the for loop looks different than the Python for loop. Right? So keyword for is the same. Right? You must use round brackets here. Right? And now instead of elem in T, right, you write elem colon ARR, and you have to say what is the type of the element. Right? So the element type is the same as the element type in the array, so the double goes here. Right? Elem is just a name, it's just a variable name, right? So you can call this whatever you want. Right? Instead of in, it's the colon, and then the name of the list, and the name of the array in this case. Right? Everything else now is the same except translating Python to Java. Right? So if elem is greater than high, high is equal to elem, and then after the end, return high. Yes, question? Is this question? You will not see, I will not ask you to write a method that finds the maximum element in an array. This is something that everyone here should be able to do without thinking about it.
Is the question related to anything like x equals 1?
I don't even understand your question.
So there's going to be a question like, let's say x equals both things, yes, this one, can it work? And is it Java like that?
There could be, but I'm not going to tell you what questions are on the test. But yes, there could be a question like that. Okay, so here, this is actually a variable declaration, right? So this variable elem has a scope, right? The scope of elem is the body of the loop. So you can use elem inside the loop, right? If you need it after the loop, this won't work, right? So the name elem does not exist after the loop. If you need to use it after the loop, you have to declare elem up here, So you'd write double elem here, semicolon, and now here you would write for elem colon ARR. And then elem would be available to you after the loop. Right? Here, it's the scope of elem is the body of the loop. Most loops that you will write, the loop variable only needs to work inside of the loop itself. Right? Usually, you don't need the loop variable after the loop. There are cases when you do. Okay, so instead of finding the largest element, I might want to find the, did I do this right? Return to find the index of the max. Oh, no, there's a bug. Boom, boom. Sorry about that. Okay, instead of finding the maximum element in a list, you might want to find the index or the location of the maximum element in the list, right? Because you might want to change that value, right? If you just get back the largest element and you want to change it, you now have to search the list again to change the value, right? So instead, you might want to know where is the largest value in the list, right? So in this case, I need the index of the element. So here, the easiest way to write this is to write your loop so that it uses the index of the element, right? Rather than using the element directly by itself, directly. So to find the maximum index, I'm going to assume the largest element is at index 0. Right? I'm going to set my current largest value to that element. Right? And now when I write my loop, right, I'm going to use a loop variable called I, or index, or ind, or in, not in, ind, or something like that. Right? Python only has one kind of loop, right? It only has the for each loop. So if you want to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you have to use this thing called range, right? So range 0, comma, length t. In Python, that makes a range object that can count from 0, 1, 2, 3, 4, 5, up to length t minus 1, right? Which is exactly what I want, right? So I is simply the range of the valid indexes for my list, right? And now, my if statement, I'm going to look at ti instead of looking at the element itself. Right, so now I need to get the element, so that's the element at index I. Right? If I find an element that's larger than the current highest value, I have to remember its index. It's useful to also remember the largest value. Right? And then finally, when I look at all the elements in the list, I can return the index corresponding to the largest element. Okay, so Java does not have, Java has a second kind of for each loop. A second kind of for loop. Right? The second kind of for loop was the original for loop in the Java language. It comes from the C language. So the original for loop in Java, or the normal for loop in Java, is a counting style loop. Right? So the way you write this thing here is that you create a loop variable the same way that I did here. Right? So I is my loop variable. Here, I is my loop variable. Right? And I'm going to set it to 0. So I is an index. All indexes in Java are ints. Right? So I'm going to set it to 0, and then I'm going to use a semicolon. Right? I'm then going to write I is less than the length of the array. Right? And so this condition here is the condition that is checked before the loop runs. Right? So if the value of I is less than the length of the array, the body of the loop will run. After the loop runs, so right here, whatever is here now runs. Right? So this is the loop update expression. Right? So int I equals 0, semicolon. Semicolon has to be there. I is less than the length of the array, semicolon. Semicolon has to be there. Right? Each time through the loop, I want I to go up by 1. Right? So I want to increase the value of I by 1. So you can increase the value of a variable by writing I++. Right? So I++ means, for the time being, it means add 1 to the value of I. Right? And now the rest of the code looks the same as before. Right? So those are the two types of loops that you're going to need in assignment 1. You now know how to use an array in assignment 1. There's only one thing missing that you don't know how to do. If you skip through this, if you go through this lecture slide, here. You need to know how to throw what's called an exception in Java, right? So if they taught you how to raise an error in Python, This is the one thing that I haven't gotten to yet that you need to know for the assignment. You need to know how to throw an exception. You can either read ahead in the slides, or you can wait for the next lecture. Finishing assignment 1 is relatively easy. You're going to translate one line of Python to one line of Java to complete a program. Right? And I'll do a little bit of assignment 1 with you in the next lecture.